I want to just, I left this piece up just really quick to sort of show you guys, because the legs, like our bodies are not independent pieces. They are all interconnected. And so as our torso and our pelvis actually connected to our legs and our lower and upper legs. And so all of these muscles, as you can see, are actually parts that are holding on to the femur. This line right here, so I can turn him around really, really quick. This line right here, these muscles that are inside and sort of underneath this gluteus maximus, this muscle is actually going in and it's connecting to this edge of our femur. And I'll show you, pull up close. I want to show that to you, just so that you understand that this is all connected, and this femur muscles hold, or this femur bone is holding all these other muscles together. You see how it, and that's that protrusion that when we see from the side, this sort of bump, bloop, that's actually the femur bone. That's actually the leg bone that's kind of protruding out from the hip socket. And so these are little landmarks. These are points that they're all kind of interconnected. The body in itself is interconnected. One part isn't sort of independent. We are all, like I was explaining before, was that the biceps are connected to the shoulders and all these other things. So I want to show too, like the quadricep muscles, the major muscle groups, right? They themselves are also attached to the pelvis. These, what we call the iliac crest, this sort of scoop bone that's sitting here that's holding all of our internal organs inside. This shape is actually, all of these sort of quadriceps, they're connected up to the top here, and they all kind of come down. And so I also just want to talk about, what does it mean to have legs and a form? Hear me let everybody in, people are joining. As we do the hips, I'm just going to do my general quick little spool form of the sort of hip pelvis experience, so that we can then expand onto the legs. The legs, and I do this sort of general shape, general circle shape, and I ran out of room, but general shape, and then a sort of an ankle. We'll kind of cut it off there. Let's see, admit all. So these are the generalized shapes, right? Now, if we go a little bit further on that, theoretically, it's not straight, and it's not straight in the sense it's up and down straight, but it's also not straight in that it's vertically straight. Our bone itself, it protrudes out, and it actually kind of, there's a bowing, there's a curving that happens, that then there's also two other, the shin curves, which is the tibia and the fibula. And those bones are basically, there's two bones. There's this little guy that's kind of hiding there. And this is our shin bone, and it's really a protected bone that's sort of protecting the leg. And that gives it that shape. It's not straight. It's actually, there's a curve and then another curve. And that's really, if you think about it, it's designed for absorbing shock. Our legs are really springs in a sense. They're just bones and muscles built together to put into springs. But that's, you have to think about, as we go through studying the body and anatomy and all of these elements in figure drawing, we really have to think about, why is this body this way? Why is it moving this way? And why are the muscles these shapes? It's not just because it looks cool, it's because it's genuinely created for function, for the body to stay stable while standing. So I just want to show that too. And it's sort of a quick example is that here's sort of the general pelvis. It's when they come out, the bone actually kind of protrudes out. There's a ball and socket bone, the joint, and that basically that femur, there's a point that sticks out that's called the great trochanter, and that line then runs down and it curves down, and then it attaches to the knee, and then that knee curves and it creates, that's that shin bone that then goes down into the ankle and the metatarsals, really, which is small versions, and we're just another foot versions of our ankles. Metacarpals is our wrist, metatarsals is our feet. And so that then goes down to the ankles, which then top of the foot, and actually if we were to just make it, it would be like a wedge shape for the foot. That generalized shape, again, it's more of a curving situation as well, if you think about it, to the flow of the muscle groups as they go up from high to low, and then it flips. And so as we then drop in and add our quadriceps, the quadriceps actually kind of terminate a little bit before the ankle. And as they come down, they actually terminate a little bit below and inside of the ankle, the knee. So the outside of the knee, in a sense, a little bit above, and then inside of the knee, for this is our knee. situation. And so these are generalized shapes that then flows. Actually, there's this flow of the calf muscle that then terminates into the ankle. And then this shape right here that we kind of, that sort of you see like soccer players, this really exaggerated, this shape. This is actually, you're seeing is the back and the belly of the calf muscle from behind. It's actually from the side, from, in a sense, this calf muscle, this interior muscle, you to turn it, and as you turn, you'll actually see it's that right here. And so it just creates this shape that even though it's in the back, you're actually kind of seeing the front of it, and it creates that silhouette, this shape. And so this is an example again of things that you don't see affecting what you do see, and those sort of forms that are invisible to the eye but are actually very relevant and actually do affect these shapes. And so, I mean, I'm squishing it a little bit, but I just want you to sort of exaggerate to understand these general flows. And sort of the quadricep muscle is that it flows like this. And actually I did it wrong. This should be come down here, and it peaks on the outer point, and it peaks out, outer point this way, in the sense that the calf muscle, the apex of the, the apex of the calf muscle is here, and the apex of the outer calf muscle is out here. And so again, the only thing is then once we get to the ankle, the inner ankle is actually higher, the bone, and the outer ankle is lower. And so it flips. And so you can kind of tell, like when someone knows anatomy, where they put their ankles, the inner ankle will always have, the bone is higher up than the outer ankle. So the outer ankle will have more, and I'll show again, I'll grab really quick. It's kind of hard to see, but the inner ankle is much lower down here. My pencil's so small. I just broke it. Here we go. The inner ankle, and this is the tough part where I can't show with a model. So it terminates right here. You can kind of see this shape right here. That's the bone of the inner ankle, and it's kind of high up on the foot. And then the outer ankle, it terminates much lower, closer to the heel. And so you can see that shifting, and sort of, this is anatomy. I know you're like, oh man, muscles and bones, but that's what makes up humans. And this is what makes up creatures, right? This is beings. This is all mammals. This can be reptiles, any sort of endoskeleton, any creature that has bones on the inside. We have a basic template, whether it's a blue whale, whether it's a chameleon or a human being or a tiger. We all have this basic structure where the arm bone, say here's the, we'll do start of the pelvis, the first bone coming from the lower leg or upper leg, or just from the trunk, in a sense, the body, the trunk, is always going to have one bone. And then it attaches to the knee, and then that lower leg, the lower appendage, is always two bones. That then goes to ankle, and then that two bones, then there's like kind of a bunch of little bones, and then there's sort of these feet, toes situation, right? And that's true. That then this sort of basic formula, one bone attaching to the trunk, two bones from there, fingers and toes. This basic layout you will find in bats. You will find it in, like I said, whales. Whales have it too. They're just their fins, except they're just way more spread out, and it's proportions, right? And what's in between. I mean, same with birds. All these creatures, we all have this basic structure of single bone, which would be, for this would be our humerus, and then the radius and the ulna. And the ulna is the bigger bone. It would be, in a sense, our shin bone. It's designed to protect. It's supposed to be like strong. It's supposed to take blows and be able to defend. The inner one is the radius that helps us turn. And so I'll go into more of that, sorry. I can easily go into we'll go into that next week with the arms. That would then be the same, would be the femur as the big leg bone, the major leg bone, and then the tibia and fibula. Those are the main bones that basically all creatures will have. Then it's just relationship and proportions. It's all just, how is it attached to the pelvis? Are they quadrupeds? Are they bipeds? Which means, do they walk on four legs, or do they walk on two legs? We are bipeds. We walk on two legs. Cats and dogs and all those other creatures are quadrupeds. So they're same proportions, same body, or it's not same proportions, but same structure, same basic template, but then is altered and adjusted based on their evolutionary basic, survival, really. So that basic template, that one and two, it helps you to also to see that it's really a design, it's a shock absorber, right? That when we step or put something down, the lower parts absorbs it, and that understanding why these curves are happening, why are these curve shaped. And last week we discussed the concept of the pelvis shape, male versus female, male being much taller and narrower, females being more shorter and wider. And as we put and attach, I'm gonna do female here, we'll attach the hip, the great trochanter and the femur to the knee. And I'm going to do the same thing for a male. I want to show you the difference of the angle and how that affects being able to do long distance or other sort of like sprinting and things. That sort of those angling, depending on the hips, you're going to be able to determine whether or not it's a male or female just on these sort of angles. And again, there always will be some tilt to it. There's always a little bit of a bowing. It's never a straight line. There's always this sort of flow that happens. There's always this, the leg itself, even from behind, or sorry, from the side, here, I'm gonna start over. From the side, there's no straight bones. There's no straight lines in the human body. So viewed from the side even, the thigh muscle, there's sort of this flow forward and then flow backward that then goes to foot. And so from here, you can almost see, I then can just drop in a knee, put in a heel, and suddenly it's becoming a leg. And this is a very stylized version, but I just want you to see how quickly I was able to render a quick leg just with a swoop and swirl. Because really what's happening is there's this sort of flow forward of the quadricep as it sort of sits above and in front of this knee, this square situation. And then the calf sort of flows backward and it's almost straight and almost kind of goes in a little bit before it kind of comes back out to the top of the foot and becomes the ankle. And so that, here we go, just sort of a wedge shape. But I just want you to think about that as it then connects, this shape as it then connects to the gluteus. But those are the basic forms, right? These are the basic shapes. This is this muscle that's sitting on top of this bone that's also bowed. Our humor or our femur that comes out, it also has a bowedness to it. It's not perfectly straight if you were to imagine and see through. And so I know it's like, man, anatomy, but this is the key to understanding what you're seeing. The more that you can see